Help, yeah? All right, cool. Can you guys hear me good? Awesome. Good morning, everybody. I hope you guys are having a great time at Devcon. I don't know about you guys, but this just has been a great week. I've seen such cool talks, and the Build Guild is here in full representation, and we're here to support you on Scaffold-ETH and building on Ethereum. So we're going to be focusing today on Scaffold-ETH. We're going to explain a little bit about Scaffold-ETH just to kind of feel for the room. Who here has actually used Scaffold-ETH before? Anybody? Or is it kind of new? Okay, cool, couple hands. Who here is a software developer? Who here is an aspiring software developer? Okay, so we got some new people. We got some people that probably have some experience coding. So I'm going to try to keep this kind of a slow pace. A lot of the workshops that we had here this week have been a little bit quick, hard to follow. So I do want to make it kind of paced at a pace where you guys can follow along, especially being new and building on Ethereum can be a little daunting. Who here attended another Scaffold-ETH workshop this week? Anybody? Few? Okay, cool. We had a lot. So who here is hacking at the hackathon? A few of you? Okay, cool. Thank you for the hands. I know you guys are probably like, oh my God. But, okay, cool. So I appreciate your guys' time. My quick intro about myself. My name is Kevin Jones. I work as a developer relations engineer for the Graph protocol, but I also am a core member of the Build Guild supporting Scaffold-ETH, onboarding and education in Ethereum. And it's actually how I got my start into Ethereum, so it's very appropriate. I continue to be very active in the community. Scaffold-ETH is a tool that has come out of the Build Guild, or the Biddle Giddle. The Biddle Giddle, just real quickly, is basically a DAO that is basically focused on education and tools for the Ethereum ecosystem. So if anyone wants to get involved with the Build Guild, you can totally do that, and I highly recommend that, especially if you're getting into software development in the Ethereum ecosystem. You can go to the Build Guild app, but really the meat and potatoes for getting into the Build Guild is through a tool called Speedrun Ethereum. So Speedrun Ethereum is this kind of it's like a challenge kind of gamification on writing and developing smart contracts on Ethereum. And so you go through this kind of process where you go through and build different projects. So you start by building a very simple NFT. You eventually learn to build a staking application and understand the concepts of staking on a smart contract. Then you build a token vendor, and then you do a dice game and you learn about randomness on the Ethereum blockchain. And then eventually you get a little bit more difficult and you can build a DEX. Once you finish that, you actually become a member of the Build Guild, so anyone can do that. So highly recommend after today, go to speedrunethereum.com and test your skills, right? Because it's a great learning experience too, because you really have to think about what smart contracts are and how they work. At any point today, if you have questions in the app, there's a questions and answer. I'm going to try to keep an eye on it when I'm here so I can see, but also feel free to raise your hand, okay? I want this to be interactive. I don't want you guys to I don't want to lose anybody. If you have a question about something, please let's get it addressed, okay? So we're going to talk about Scaffold-ETH. We're actually going to use it. We're going to walk through how you use it, and the idea is by the end of today, we're just going to deploy a smart contract, probably to a test net, maybe like Base. I don't know. We'll see. But if you want to get started on Scaffold-ETH, everyone should go to scaffold-eth.io. Okay, there's two ways you can install Scaffold-ETH. You can clone the repository and install the dependencies using the Git repo, or you can use the npx script method, the package, the create ETH package. It's the easiest. It says beta here. I've been trying to get that to go away, but we need to remove that. It's fully functional, and it's really probably how you should install it, especially if you want to use Foundry. If you use the Git clone method, it comes with hard hat. If you want to use Foundry, you want to use this method. So all you need to do, but let's just look at the GitHub repo real quick. The main benefits to Scaffold-ETH, and I'm going to show it off, but is that it is kind of like complete with everything you need to like build a dApp, really. It's great for hackathons. It's great for prototyping. It's great for like local first development. So you can like build locally and you don't have to deploy to a testnet. You can use just the local chain and the local front end that you have, and it's just got all this stuff working for you. It runs with some requirements, so you need Node.js on your machine. You need a Yarn package manager, and you need Git. So just one little bullet on Yarn is make sure you have the newest version of Yarn. Make sure you install that, because if you have an old version of Yarn, you might have some issues. And if you have problems with Node versions, just try 18 or 20. Those are kind of the most compatible versions. If you're running Windows, I would use WSL, so the Linux installation for Ubuntu, and because it's going to make it a lot easier. I don't think it's really easy to use just like native Windows. Okay, so let's get started. So let's do exactly that. Let's go to npx create ETH at latest, right? So if you have a terminal, open it up, go ahead and type that in. So this is going to ask you, if once you first do that, it's going to ask you if you want to install that package. So that will just take, a little bit of time to install that, and then it wants to know what you want to name your package. Can you guys see that okay? Yeah? Anyone have? Make it a little bigger. Okay, so we're going to name this one Devcon app. Sure. It's going to ask you what kind of chain you want to use. So we support both Hardhat and Foundry. Personally, if you're new, I would recommend Hardhat. If you're more familiar with TypeScript or JavaScript, I would use Hardhat. If you're more like into the solidity aspects of Ethereum and blockchains and stuff like that, then Foundry might be a better option. Foundry is a little faster. You can write your smart contrast tests and your deployment scripts in Solidity, so it's a little bit less of a learning curve if you don't know TypeScript. But personally, I think Hardhat has been around a little bit longer, so I use that. You can also do no chain if you wanted to just use it as a front end. A lot of people do that for different reasons, but so it's going to go through and install the packages. Okay, so this takes a little bit of time depending on your internet connection and your machine. So we'll just let that sit for a second. Another thing about Scaffold-ETH is, again, I mentioned it's a local first, right, kind of tool. So you're running a chain on your machine, and you're running a front end on your machine, and then you're using another kind of terminal to do deploys. So you need a few windows open, okay? So you can just open multiple terminals. That's fine. What I use is a tool called Tmux, which lets me kind of split my screen up. So I can do like this, and I can split my screen into kind of a few different ways, and then I can go into this Devcon app folder in these other folders. But you can just do this in like 3 windows. So just open a new terminal, go into the same directory on each window. So it's still installing the packages, so we'll give it 1 second. Let's go just really quick and go back to Scaffold-ETH.io. The next thing you're going to want to always do if you're just getting started on Scaffold-ETH is take a look at the docs. The docs are super good, super simple, but they have exactly what you need to know. If you go to the quick start section, it gives you the how to install all the requirements. It tells you how to set up your environment. So it talks about how you bring up your blockchain, and we're going to go through this, where your configuration for Hardhat and Foundry is, how to do a deploy. And then the components section is super awesome, because these are packages that come with Scaffold-ETH that give you some really cool added functionality out of the box that you don't. So especially if you're not a front-end developer, it's very difficult when you first start writing smart contracts and hooking that stuff up to your smart contract. So an example would be like if you want to get an address and you want to get the balance of the address, or just do like ENS resolution, there's a component for that, so you can use that. We're not going to be focusing a lot on the front end stuff, but tomorrow Edda is doing a workshop, and if you are struggling with that aspect, I highly recommend you do that, because she's going to focus on some of the front end stuff. We're going to pretty much just do smart contract stuff today. There's also a balance component, which is cool, so you can see what the balance of an address is. There's an address input that you can type in an ENS, and it will resolve it to an address for you. A lot of cool stuff. Ether input, so it'll figure out what the dollar amounts are at the current time based on the input. And then the last part I just want to show real quick before we get started is the interacting with your smart contract. So there's also hooks in Scaffold-ETH for reading from your smart contract or writing. So if you want to read some data from a contract in a specific function, you can do that. You can pass in arguments. If you want to write a transaction to the blockchain from your front end, there's a write function for that, and that is also available in here. So like this is an example of a button that will basically call a function called greeting, set greeting with a value passed as an argument and maybe value as like a transaction, like maybe you want to pay in some value in the transaction, and then does some error checking, and it's a really nice component, really easy to do. Okay, so again, this is not a front-end course, but I just want to mention that if you're first getting started, that's a great place to go. Okay, is it done? Yes. Okay, cool. Bought myself some time. All right, so we have the package now set up. It's kind of ready to go. So we're going to go into our Devcon folder in this one, and we're going to run yarn chain. So all this does is Scaffold-ETH is a mono repo. So what that means is it has like multiple packages in one. And it has this package JSON file that has a bunch of scripts that you can kind of just type really easily using the yarn command. So yarn chain runs whatever local chain you want to use. So in this case, we chose hardhat. So what it does is it spins up the blockchain on the local machine, local host, and then it gives you these private keys and public keys that you can test with, right? And then, so if you wanted to, you could inject those into like your MetaMask if you wanted to or something. But we're just going to use something else, which is really cool about Scaffold-ETH that I'll show in a second. And then this other window, we're going to open up our front end. So you always have your chain open, and then you always have your front end open, okay? I'm having a bad typing day today. Okay, let me warm up my fingers. All right, so we now have our chain running, and we also have React running. So Scaffold-ETH also comes with React with Next.js, and it is the app router implementation of that. I'll show it off in a little bit here, but it's up and running. It's ready to go. It's on port 3000. Let's go ahead and just open up Scaffold-ETH over here on port 3000. Everyone following along? Yeah? Cool. Anyone having yarn errors? Hopefully you're not. A few? Okay. So just make sure you're using the newest version of yarn. And also, yeah, trying to think what else. That's pretty much the main thing. Make sure you're using a new version of yarn. And if you have to change the version of Node as well, sometimes there's like issues with different versions of Node. You can use NVM, which is Node Version Manager, to swap Node versions. 100% recommend that too. Okay. So Scaffold-ETH is up, right? We have it up and running. If we first see Scaffold-ETH here, it's very basic, but it gives us this our connected address. It's kind of like a hello world page. It tells us how to get started editing our application. It also tells us where our smart contract is that comes with Scaffold-ETH. But it's also, what's the really cool thing is this debug contracts tab. So right up here, it's debug contracts tab. This is kind of the magic sauce of Scaffold-ETH, because one of the hardest parts of understanding writing a smart contract and then interacting with your front end is every time you create a smart contract and you compile it down into bytecode, it also generates an ABI. Okay, so the ABI is this kind of like treasure map, or like how you actually can navigate all the functions and the variables in your smart contract. Now what Scaffold-ETH does is when we deploy our contract, so we come down here and we do yarn deploy, and come back, it's going to give us some output here. It's going to say, okay, cool, the contract was deployed successfully. This is how much gas it took. This is some output that we get from our deployment script. And then we see some terminal output here with console log, so we see what's going on. And we see that our front end also refreshed. So if we go back there, we get everything that's in our smart contract inside of the front end, okay? So that's really powerful because you don't need to go in there and write, front end code. It's just ready to test. So we can kind of look at this and know exactly what our smart contract looks like. It's got some greeting function or greeting variable. It's got an owner variable, which is an address. It's got a premium, which is a Boolean, and it's got a counter, which is an unsigned integer. And it's got a read function, and it's got two write functions, right? So it's got this greeting that I could change the greeting. So I could say hello world or something like that. Or actually, let's do hello Devcon. Okay, like this. And if I try to hit send, it's going to tell me I don't have any gas. So the next thing you'll learn about Scaffold-ETH is you get this burner wallet as well. So you don't need to connect to MetaMask. You can just start transacting. There's a faucet button. You grab some funds from Hardhat or Foundry, then you can go ahead and interact with your smart contract. So I just paid some gas, I got a transaction receipt, which has all the details of the transaction, and I updated the state of the greeting variable. So very simple. So if we go into our application and we look at that, we can see that's exactly what our smart contract does. So let's do that. So here it is. I use VS Code, zoom in a little bit. So again, Scaffold uses the mono repo. So we have this hard hat folder, okay? And inside there we have this contracts folder. And then we have the your contract. So this is a very basic contract. It has the hard hat console. So this gives us our console logging output that we see on the left terminal that I have. We have a basic contract called your contract. It has a owner address variable. It has the string right here. So if I come in here and say building cool apps, save that, redeploy, and then I come back to Scaffold-ETH, we will see that my greeting will change here in just a second. There it goes. So now it's reflected my changes. So a lot of the life cycle of using Scaffold-ETH is that you just come in here, make a change to your smart contract, deploy your contract change, and then test your changes, right? It's a way for you to like test your assumptions, as Austin Griffiths likes to say. So, okay, cool. So we have this very basic contract. It has a Boolean, it has a counter, it has a mapping, which is cool. So it keeps track of like how many greetings a particular address has done. We'll use that when we build our smart contract. And then we have like some events, which events are like logs on Ethereum. Who here would say they're new to writing Solidity? Just a few newbies. So when you're writing Solidity, everything is very simple. If you've written any other program language, it's very simple to get started on Solidity. If you don't already know about Solidity by example, it is the most probably important website you'll probably be using over the next year. It's going to have every single example of every single functionality inside of Solidity, and I highly recommend that you guys come here and kind of start using Solidity by example to test different functionality. So there's like a hello world, there's a first application which does like a counter, and it allows you to like see how you increment the counter. And this is just a great resource. So if you're coming in here, we kind of have this kind of basic contract that's a hello world contract. It has this event, which is like logging. It has a constructor. The constructor is basically like at the time of deployment, you might want to set some values. So in this case, we set an owner at the time of the deployment. So we pass this into the deployment script, which we'll go to and show off. There's a modifier. So what I want to do actually is I just want to kind of like gut out this contract. I want to show you that you can kind of just start from scratch and go from there. So you should come into this contract and you should, let's just get rid of some stuff so it's easy to see. I still want to use hard hat console, right? So I'm going to keep that. I want to get rid of all of these variables. I also want to get rid of this. I want to get rid of this event. I need a constructor, but I want to get rid of the stuff that I'm passing in the constructor. And I don't want this modifier anymore. I don't want this function anymore. I want this function because this is an important one. There's two important functions here that I want to keep. One is a withdraw function. Did I break something here? Oh yeah, okay. There's this one function that is a withdraw function, which allows me to withdraw all the funds from the contract. And then there's another one that allows the contract to receive ETH, even though there's no receive function, so it gives you that ability. We also took away the modifier, which we'll get rid of that. We also don't have this owner variable anymore because we deleted that. So we actually want to use message.sender. So let me kind of show you what I did. Ooh, okay, so what I did is I just took everything out. I kept the constructor. I kept the name of the contract, which is we want to use this year contract because we also have a deploy script that's down here, but I'll get to that. And we just emptied out the constructor, so there's nothing being passed at the time that it actually gets deployed. But we keep this because we want people to be able to come in here and withdraw the funds from the contract, especially if it's mainnet. This might get some funds, and we don't want them locked in the contract forever. So what this does is it allows people a user to make a withdraw function or call, and anyone who does that who is the sender can do a .call and get the value, which is the balance of the contract. So we can basically rug pull this contract, and then we can basically pass a success, okay? Or require, which in Solidity, a require statement is something has to happen, otherwise the transaction will be reverted. And then this last one, like I said, is just so that if someone tries to send ETH to this address, we still want it to be able to receive ETH. So it just allows that receiving. So it's like a payable function, okay? So yeah, so we basically wiped it out. Let's save that, and let's try to deploy. So if you guys do that, you're going to get an error. You're going to get a couple errors, actually. So we could look at the errors in real time. Let's do it. So this one's saying, well, I expected 0 arguments, but I actually got 1 argument when I was doing the deploy. So if we go into that deploy script right below, so again, we're using hard hat in this version, we are using TypeScript to deploy the contract. Let me get rid of some of these comments so you guys can see what's going on. But what we're doing is we are getting we're getting the list of hard hat accounts that are available to us by doing this calling .get named accounts. And we take the very first one and we use that to deploy the contract. So we use that private key, the hard hat private key. And then we call the .deployments to do that, to do the deploy. And then we create a deployment right here by using the await. So an await is like, hey, you need to wait until everything is done before you continue in this code. And we deploy the contract. Now, we say who the transaction is from, right? Who sent the transaction, and what were the arguments that need to happen in that transaction. So this is where the constructor arguments are. So as we mentioned earlier, we took away the constructor arguments, so we also need to take away the arguments here, okay? And we also have logging enabled, and we have like auto mine true. You can take those off if you wanted to. We'll just keep those there. And then if we save that, and then now try to deploy, we'll get a new error. But this is what you do in software development, right? You work through errors. So then you're going to see, well, we got a type error in our deployment. Inside of our deploy contract, we got this your contract.greeting is not a function. So let's go back. So another thing you'll notice is we get an instance of the contract right below here. So we say, okay, if you have deployed your contract successfully, take that and get a contract by using get contract from Hard Hat Ethers. So Hard Hat Ethers is an Ethers implementation for Hard Hat that allows you to query the blockchain basically to get the instance. And we query it by calling the name, which is here, and we query it by calling the owner, or who it's from, is the deployer. And then once we have that contract, we can call any functions inside of it, which is really cool. So we can actually do some transactions here inside of the deploy script. Or we can, so in this case, what we're doing is we're doing a console log, and we're logging your contract.greeting. But this doesn't exist anymore because I deleted it, right? So we also need to get rid of this, okay? So if we save that and then deploy again, we should be in the good. There we go. Cool, successful. Okay, let me zoom back in. No more errors. So hopefully you guys have been able to get to that point. So you should come in here, you should wipe out the contract. You don't really need this withdraw function. You could get rid of it too. You could get rid of this if you want. We just want to start from scratch. So what I want to do now, and then you need to come in here, make sure you remove the arguments from the args, make sure you remove this console log that you were doing here and right below that, and then you'll be kind of where I am. I want to pause a second for questions because I know there probably some people might have questions, so let's just give like a couple minutes to answer questions. Put your hand up if you have a question, and I'll check the app real quick. Any questions? No? Yep.
I was more focused on following up with the code. I didn't really get why did we do these changes.
I'm going to build out a new smart contract right now. We're going to create an ERC20 from scratch. So we want to, it's kind of just when you're first using Scaffold-ETH, it comes with this stuff to test and see how it looks, but you probably want to just start from scratch. So I wanted to show you guys how if you're doing a hackathon, you can get rid of all the stuff you need and just kind of start at a new base.
And why these specifically? Like why the argument and the other line below?
I'll show you, but that's a good question. So the question was basically, yeah, like why are we removing the arguments? Well, this contract comes with a what's called an ownable pattern, or like an ownership pattern, where that owner address is kind of like the access control for withdrawing funds from the contract. We're actually going to use Open Zeppelin to do that, and so I'm going to show you why in a little bit. There was a couple questions in here. Let me just read them real quick. So, can you share the main difference between Scaffold-ETH hooks and WAGMI? We use WAGMI for some stuff like getting the account, but the hooks, they're just kind of custom, and they were kind of imported from the previous implementation of Scaffold-ETH. So they were kind of rewritten to be more optimized. I think they just are designed for Scaffold-ETH, so that's kind of why that's how they're different. Can you navigate a conflict? That's a silly question. What VS Code extension do you recommend? Definitely the Solidity and TypeScript highlight syntaxing. I actually recommend Cursor. I don't know if everyone used Cursor yet. If you're not using Cursor, at least like a couple days of the week, try it out, and you will really, really, really start to develop a little quicker. Okay, those are good questions. Any more questions in the room? Yeah, over here.
I'm getting an address and use problem for when I run yarn chain after running it before and closing it out.
That's interesting. It sounds to me like it's still running somewhere, so maybe you have it in another terminal that you didn't notice. Double check. Maybe just do like a PS and see if you can find the binary. Are you running a Mac, yeah? Or it's Windows? Windows? Linux. Yeah, just do a PS like AUX, like this. Grep. I don't know, what is it? Foundry? Oh, you were using Foundry, right? Something like that. And see if you can find the process ID. And then try to kill. So do like a kill-9 process ID. I'm teaching you guys Linux too. Okay, cool. Yeah, try to just kill the process. That should get rid of it. Okay, let's keep going. I think we answered a couple questions. If you have a question, ask it in the app, and the next time I stop, we'll go. Okay, so we have our chain running. We have our front end running. Let's start writing a contract. We've wiped out the contract to at least a very base kind of spot. The name of this workshop is about smart contracts. So let's try to write one. Just let's hope I don't mess it up. But let's see. Okay, so what I want to do is I want to create an ERC20. But first I want to start by having access of this contract in a way that is probably the standard, okay? So we were using this kind of like, we don't want to use Open Zeppelin, we want to use Ownable. Let's see if that works. Actually, let me grab it from here because I forgot what it is. There it is. Okay, so we're going to use Ownable. Now, the beginning contract Scaffold-ETH comes with this kind of access control pattern where you have an owner of a contract, and only that owner can do certain things, right? But the standard way to do it, the easiest way to do it, is just to use Open Zeppelin Ownable. So we're going to do that. We're going to import Ownable, which is an access control contract that allows me to just take everything that's in this contract and import it by doing your contract is ownable, like this. And what that's going to do is it's going to allow me to deploy at the time of my deployment. Okay, so it wants something passed in the constructor, which I think, let's see if we can do that. I forget how we need to do it. No arguments passed. So I think it wants the owner passed here. So we can set the owner. So what I want to do is I want to use my contract address from the contract burner wallet that I have. So inside my burner wallet, so now that I've done my deployment, the script, or the smart contract's pretty much empty. I want to use this address here in the burner wallet as my owner. Okay, so I'm going to copy that, and I'm going to pass that into the arguments, which I think is what I need to do. Let's see. What is this? That should work now. Let's try to do the deploy. Let's see. Oh. Address, constructor address, initialize owner. Yeah, that should be it. Oh, I need to call. So what's interesting, I think I need to do your contract deploy. And is it ownable? frick, I'm trying to think what I need to do. It's in the constructor. Oh, yeah, you're right. Thank you very much. So it's not here, actually. It is here. Like this, right? Ah, thank you. So we do it. So like this? Oh, I got you. Okay. So owner like this? Can I do it like that?
I would say that.
Yeah.
You can take the arguments from the deployment if you want. No, it's fine.
Okay. Well, all right. That's okay. Let's actually not do the ownable stuff. Let's just focus on the actual smart contract for the ERC20. I don't want to hold this up. Let me just redeploy those changes real quick. Okay. So the basic functionality of a token is that you have like a name for the token, you have a symbol for the token, you have a total supply of how much tokens that you want to have, and then you want to like mint that token to a particular address. And then you might want to like sell that token on a exchange or something like that. So let's try to actually do that. Let's just try to make a token. So what we'll do is we'll do a string public name, and we'll call it, I don't know. Everyone's talking about these frogs, so I'll do frogs. How many frogs do you guys have? Okay, so, and then we'll also do string public symbol equal frog, sure. And then we can also do a total supply. Let's do, 1, 2, 3, 1, 2, 3, 1 million times 10 to the 18th power. So in Solidity, or I should say on Ethereum, you have this concept of decimals, right? Sorry, I spelled this wrong. What am I doing wrong here? Oh, thank you. Gosh, I'm like failing today. Okay, so you have this concept of basically decimals. So if we want to have 1 million tokens, but we also want to have the the full amount of decimals available, we want to multiply this by 10 to the 18th power. So we want to set the total supply to 1 million tokens, and then that way it can be converted down. So we have this kind of like total supply. And so we can save that and then do our deploy and kind of show what that looks like. So we do the deploy. And then when we come here, we can see that we have the variables are showing up, we have the name, we have the decimals, we have the total supply, and then we have this cool functionality here where we can like convert, sorry, it's a little hard to see, but Scaffold-ETH can convert it from the standard Ether values all the way down to what it would be in 10 to the 18th power. And so we can see what the total amount of way is that this token is worth. But we don't have any way to, well, first of all, we haven't minted that. We have the supply, but we haven't actually transferred the value of that. And so the way that we do that with Ethereum or Solidity is we create a mapping. So we say, we want to keep track of the balances of any address that interacts with the smart contract and has some kind of like balance, transfer of balance. So we use what's called mapping. So mapping takes one variable and essentially maps it to another variable. And so in this case, we want to take in an address, so any particular address that has a balance, and we want to exactly tell how much that balance is. And we want this to be publicly available so that a user could query what their balance is. And when you do this with Solidity, you get a get function, so you can actually see what this balance is. So if we query that, so let me just save that, and then in here, we can set the balance of a particular address at the time that the contract deploys to anyone we want. So we don't want to actually send it to message.sender. I want to send it to my burner wallet, so it's here. So I'm going to come in here, copy the address, and then I'm just going to paste that in here. Cool, so let's hit send. There we go. So now we can deploy our contract. Cool. So our contract is deployed, and we can see that how much gas it took. And then if we go to Scaffold-ETH now, we should see that we have this new read function, right? So we can grab this balance of this address, paste it in here, and do a read. So you can see how you just paste in the thing. It gives you this like little blocky dude, and then you can do a read. So this is how much actually tokens that we have. We can convert it by seeing exactly what that is in ETH, and then we can go back and forth. But now we don't have any way to actually like transfer the tokens around. So we probably want a way to transfer. That's the next thing that comes in a standard token. So then what we can do is write a new function. So we will do function, gotta love AI, it just kind of does everything for you. So what this is saying that is we need to write a function that transfers by taking in a to address and an amount that we want to transfer. This should be publicly available, and then at the time that someone calls this function, you want to do a check, basically to make sure that they have enough tokens to send to another user, because otherwise they'd be double spending, right? So we just do a little, like a require statement, and then after that, we just update the balances. So we say, okay, well, the balance of the person who is calling the function. So in Solidity, you have these kind of like global variables, which message.sender is the person that is sending the transaction. So that's the user, their public key, basically. And if someone's calling the transfer function, we want to remove the amount that they're going to send, and then we want to, whoever they're actually sending it to, we update that mapping to with the amount. So here we subtract, here we increase, okay? So now we can hit save, and we can do deploy. Cool. So now we can go back to Scaffold-ETH, and we can see that we have this contract. And you'll notice that every time we do a deploy, we can force a deploy by doing a yarn deploy -- reset. And you'll see the contract address up here in the top. It will change, and you'll constantly get a new contract. And so that's why we're kind of like starting over from scratch every time, because the nonce is changing on the deployment. So now we have this contract. We have a very basic ERC20. It's called Frog. The name is Frog, so it's got a total supply. I have a balance of whatever, 1 million tokens right here. So if I want to transfer some tokens now, I can say let's transfer to Vitalik.eth, and let's send him some Frog tokens, sure. 777. Now, again, we need to transact in Way. So Scaffold-ETH has this really cool tool that you just click the little button, and it will multiply whatever value is in the input by 10 to the 18th power. So I click that, and that will tell me exactly how much Way that I need to call in the transaction, and then I can go ahead and hit send. And as you can see, it did this nice ENS resolution, and we can see Vitalik's photo. I'm really sad Vitalik changed his little rainbow cat, because that was a really cool one, but now it's his face. So there we go, we have send, and then here's the receipt, so we know that it was successful. And now we can come up here and query against Vitalik's address. So Vitalik.eth, and do a read. It resolved, and then now we can see that he has a balance of 777 tokens. So we've created this kind of like very basic implementation of a ERC20. So I want to show you how to do the other method. So let's actually do, let's take a look at OpenZeppelin. Let's see, OpenZeppelin ERC20. Let's see if I can find it here. So you probably don't want to reinvent the wheel. Again, like we're going to try to use the, okay, this is going to tell me how I can fix the ownable thing as well. We want to probably just go ahead and use OpenZeppelin, right? So you probably want to reserve the time that you're working on your smart contract to do something new and innovative. Since ERC20 is a very, very good standard, we can just use OpenZeppelins, okay? So we can grab this here, and we can come back here, and let's just kind of like take away all this stuff we did and show how much easier it's going to be if we just use OpenZeppelin. So we'll do this, and we'll go here. So we can say your contract is ERC20, and then what we need to do is we need to pass the stuff inside of the constructor. So this is what I was not able to figure out earlier, that I don't know why I wasn't thinking about that. But with ERC20, it has a constructor, so it has its own constructor. So when you're deploying an instance of another contract, you also might have to call its constructor. So this is how we do that. We call this here. And so in this case, we wanted to do frogs and frog like this. And then here we can do _mint. So there's already a function that's available to mint tokens, okay? So instead of us writing that function or that line of code to actually like create the tokens, we can just call this mint function. Okay, so what this will do is it will do 1, 1, 2, 3, 1, 2, 3. So it's 1 million tokens. times 10 to the 18th. I think we can do it like that. Let's see if that works. Yeah, there we go. Okay, now let's try to deploy again. So, and we could also probably add ownable now, I think, as well. So if we do, well, let's try to do that afterwards. Okay, so we have the ERC20. Let's deploy it. We already did. It's successful. Now if we come to Scaffold-ETH, what you'll notice is we have a complete token with just a couple lines of code, as opposed before we had to like write all this different code. So we have this token that has a decimals of 18. It has a name of frogs, symbol of frogs. It's got its total supply. But what's cool is it's going to give you all the functions that come in the other contract. Okay, so since we're importing ERC20 standard, we get the allowance read function. We get the balance of that we had to write manually last time. We get the approve pattern for an ERC20, where you have to like approve the spending of your tokens before they're able to be spent. And we also get the transfer function, and we get transfer from, where we can transfer from another address to another address if we have the approval. So it's a little bit more complete, and it's a little easier to implement. So you should always look and see if there's like a standard that you can use. I always like to go to cookbook.dev. I don't know if anyone's heard of cookbook.dev, but cookbook.dev is a really good spot to find contracts that you might be thinking about creating, and so you don't have to reinvent the wheel. So if I come in here and like, let's say I want to look at ERC 721, we can do a search, and we can find different implementations. So here's a soulbound NFT, right? So if we want to do a soulbound NFT, we could come here and it's going to give us an example of what the contract should look like. Also, what's cool about here is you can download it with Scaffold-ETH as well. So you can click this little icon right here, which is Scaffold, and it will basically download the entire package for you. And it's basically an entire installation of Scaffold-ETH. And you can just spin up your environment with that exact contract inside of Scaffold-ETH. So it's super powerful. Okay, so okay, we have this token that we've created. We used ERC20 standard. Let's just, I want to show you guys how you add another contract. So you might want to add another contract at some point because you might have a more complex application. So in this case, we have, it's called your contract. So we also might want to do like new file, and we might want to call it another contract like this, and then we can grab this entire thing, paste it in here. But let's just get rid of some of this stuff, and I don't know, we'll just say like, get rid of the constructor, it's not an ERC20. We'll just do, I don't know, we'll do something like string hello equal hello world. I'm not sure. Okay, so we have this other contract that we want to deploy, but how do we deploy it? So we can, if you're using Hard Hat, you can come in here and create another deployment script. So what I'm going to do is take this contract and make another deploy script. So all you need to do is do a new file and do 01 underscore deploy underscore your, or I should say deploy another contract. So it's going to go in order of the leading zeros. So this one would be deployed first. This one would be deployed second. We can paste that in. We also need to update, instead of deploy your contract, we want to replace everything with another contract. So what we'll do is we'll find anything that says your contract, and we will replace with another contract. Let's see if that works. Cool. Boom. So now we're doing the exact same deploy on this contract. So now we have a new contract here that just says hello, and we have another deploy script for it that's here. It's called another contract. So we took this, copied everything, replaced everything that says your contract with another contract. Oh, I'm missing one here. There we go. Okay, now let's try to deploy that. So that should give us two contracts now. What did I do wrong? Oh, is it? Did I not do it completely? Here? Oh, thank you. Thank you. This is the best audience ever. You guys are helping me. Okay, cool. There we go. So now that should work. So basically, we have a second contract. Now what's cool about Scaffold-ETH is it will show you the other contract here at the top. So we have this contract, which is our ERC20, the frog token. And then over here, we have another contract, which just has this kind of like, oh, that's weird. Where's the variable for it? Oh, it's not public. So it's private. So defaults to private. So we need to make that public. Redeploy our changes. And now we'll see this kind of like string that shows up here. There we go. Cool. So you probably are going to make a way cooler smart contract, right? You'll probably do some more interesting things. If you want to get some ideas of like smart contract stuff, I would just, like I said, look through Cookbook Dev to see what kind of other contracts are available for you to use. If you're trying to like create a new contract, it just takes time to kind of like innovate and do stuff like that. If you're new to Solidity, again, you should go through Solidity by example and just understand how things work. There's also, I don't think I talked about it, but there's a great set of YouTube videos. I personally like to learn by videos. So if you go to the Smart Contract Programmers YouTube, which is this guy, there's a bunch of playlists that are available for different things. And there's one just for Solidity 0.5 examples, and then there's another playlist here for Solidity 0.8. So definitely recommend watching both of those. I think most of the time that they might be embedded in here sometimes. No, so you kind of have to look them up. I think he needs to like put links so it's easier for people, but yeah, for the most part, you can find for all of these examples that are on the left, you can find related videos that explain in like detail of what each line of code does and why. He's a really good teacher. Okay, so let's pretend that we kind of have this contract. First of all, I'll stop for a second and see if anyone has questions, and then if not, what we'll do is we'll try to deploy this contract, okay, to a testnet. So show of hands if anyone's stuck or has a question so far. Anybody? Good? Bueller? Okay. Let's do this. All right, let me just make sure there's no questions here on this thing. And then what we'll do is we're going to try to deploy this contract to a public testnet, okay? So, no questions. Looks good. Okay, so the first thing is that we don't want to use the private keys that are stored inside of the different chains. So we have Hard Hat or we have Foundry. They come with private keys and public keys. You don't want to use that when you move into a testnet. So the first thing that we actually need to do is take our implementation and we need to generate a private key, okay, our own private key. So Scaffold-ETH actually has a function for that. So you can do yarn generate. So depending on which chain you're using, if you're using Hard Hat, it's going to just create a .env file with your private key inside of that file. That's what you should keep secret, obviously. And then it's going to give you your public key here, okay? You can also do yarn account. And what this is going to do is it's going to give you a QR code that you could scan to basically fund that account. So I'm going to go ahead and do that. I'm going to use my Punk wallet to send some Sepolia-ETH here. We'll deploy to Sepolia. So I can, I have Scaffold-ETH was also used to build punkwallet.io. So if you guys haven't seen that, it's really cool. You can have this burner wallet inside your browser and you can fund it and it's stored in storage, like the private key. So it's not good for public stuff. I wouldn't recommend it, but it's good for like test nets. So we have this ability to scan the QR code with the camera and then I can just send some ETH to this deployer account. So I'll send in 0.1 ETH, sure. Okay, so I just sent that ETH. We'll give it a second. So now if I do yarn account, oh, is there a question? Sorry. I'm going to use Sepolia. Yeah, just because Sepolia is easy. Also, base Sepolia is pretty easy. I mean, shoot, you can deploy to base these days pretty cheap. So, but yeah, let's see. It might take a second for the thing to go through. It takes maybe like 10 seconds. Let's see. So if you do yarn account, it goes out and checks the balances. Where did it actually go? I hope it did. That's weird. Let me just make sure that I got the address right. I don't think it got, yeah, that's the right address. Let me just try sending a little bit more. Okay, you're on account. Okay, let's look at this. Let's look at the scan. Sepolia, Etherscan, and we'll put in this address and let's see if it has a balance. It could be that the Yarn account is not showing us the balance, but it actually has one. Yeah, so it has some ETH. It has 0.2 ETH. So I funded it from my phone, sent it over. So now what I'm going to do is I have a deployer key now, private key. So what I can do is deploy my contract. So there's a couple ways you can deploy your contract. With Hardhat, you go into the Hardhat directory, and there's a Hardhat config. And inside of here, we have a configuration of what deployment we want to use. So in this case, the default network is currently set to localhost. So we've been like doing everything locally, but now we want to put it on Sepolia. So we're going to replace this with Sepolia, like that, hit save. And then now we're going to go ahead and do a deploy using Sepolia. So we could also, if we didn't want to update the config, we could also do -- network, and you can just type Sepolia as well. So it's either or, right? So let's just go ahead and do a deploy. So what this is going to do is it's going to take the contract, try to compile it, which it didn't need to, and now it's going to propose a transaction and then try to basically do a contract creation. So it's a little slower, obviously. So we got it deploying right now. What did I do? Insufficient funds. Okay, Sepolia is expensive right now. Okay, let's try to send some more funds, let's say. It's probably because of the ERC20 contract. Let's do 0.25, sure. It's Sepolia ETH. We have lots of it, so. You're on accounts. Let's try. Okay, let's try now. Yarn deploy. Insufficient funds. Oh my gosh, it's so expensive. All right, I'm just going to send a lot of ETH. I'm just going to YOLO like 1 ETH. Let's do it. Oh, I don't have that much ETH on here. Okay, I got to get it from somewhere else. Let's do right here. Let's do here. Let's grab the address. Sorry. Where's the address at? Boom. I'm just going to send some ETH from this other wallet that I have, which has a lot more. Okay. Okay, so we do send, paste in that address, and let's send, I don't know, ETH. We want to send, should send like 2, sure. What? How do I not have that many funds? Oh, thank you. That wouldn't have been good. Yeah, where's Sepolia at?
First one.
Did I go by it? Where's Sepolia?
It's in the bottom. Show test
Oh,
window.
yeah, thank you. It's so weird because I have like some test nets in the top. There we go, and that's a lot more. Okay, let's try sending that to there. Okay.
In the log is showing balance 0. Are you sure you passed the accounts in the Sepolia network config? The balance is shown 0. I think it's a wrong account.
Huh.
Because 0.2 is way more enough to deploy a simple contract.
That's weird. Though maybe it's
I mean, in the hard hat config file.
Oh, in the hard hat config, yeah.
So Sepolia accounts, Sepolia config.
Sepolia config.
Default network Sepolia, yeah, networks. What's the private key?
Yeah, I should be using deployer private key. That should be right.
I think accounts you have to pass -- network, Sepolia, and see what's the price. When you did Yarn account, I guess.
Yeah. Let me just double check. Account. So this. Yeah.
Doesn't look like it. Yeah.
What's that? Oh, you think? Oh, you think I'm doing? I need to do -- network flag here, like that? Oh, yeah, but yeah. But I just looked on Etherscan. I just looked on Etherscan and I thought it said that I do though. Right? If we go here. I have
nice.
balance. Yeah, so it seems like it's checking. Let me just try this. Let me see if this will work. Something weird's going on.
Oh, can you just import the private key into MetaMask and confirm the wallet address? I think it's two different accounts.
Yeah.
The .nl, you have the private key there, right?
Yeah.
Yeah.
What is it? Let's see, packages, hardhat.env, I think.
No. Accounts.
Yeah, accounts, thank you. All right, let's see, add accounts, import accounts, private key, boom. Let's see how that works.
Okay.
Yeah, it's weird, yeah, it's not.
Oh, it's weird, yeah.
Yeah, I don't know, it's something weird's going on. Unless it's something with the RPC provider. It might be that, actually.
Yeah.
Because I'm using the public RPC, but. Okay. Well, okay. Yeah, I'm not sure what's going on. It's very weird. Let me just double check the config real quick. Default network Sepolia. Default. I don't need to change anything here, right? For the deployer now. Should work. This is for named accounts, so that should be like what it's using for local stuff. But for Sepolia,
Maybe you can try OP Sepolia.
do what?
OP Sepolia.
Oh, like another network? I don't think that's what it is. Because he's right, it does say 0 here, balance 0. So it's almost like it's not pointing at the right network, or it's the RPC endpoint is wrong and it's just defaulting here. Like maybe this needs to change to Alchemy. Let me try just doing that real quick. So alchemy.com, let's see. Did I spell it right? No. There we go.
You can take another RPC from chain list.
Yeah. Let me just try this real quick. The demo gods do not like me today. Okay. Come on. There we go. Okay, apps. Let's use this test one. Sepolia. I wonder if this will work if I just use this one. Now I'm just curious more than anything.
Oh, can you go to the packages directly and try manually deploying it, like packages/hardhat?
Yeah, I'd prefer not to though.
It's using toolbox, so the deploy
Yeah.
function is there.
Hmm. Oh, this is mainnet, but where's the pulley at? There we go. Let's try this. Sorry guys, sorry we're having issues. This is unexpected. The good thing is there's like a billion videos of deploying. Oh yeah, yeah, well, let's just try to deploy. Let's see if it works. There it goes. So it's the RPC provider, man. We got to fix that in Scaffold-ETH. We just changed the RPC provider, and because we were having issues with Alchemy blacklisting our API key. Cool, it's working now. All right. Woo, that's fun. All right, cool. So we're going to deploy our contract now. As you can see, it deployed successfully. Tells us how much gas we got. We have the TypeScript definitions were created. Now, what we want to do is change our front end. So let's get rid of this. We want to change our front end to also point to Sepolia now. We're still using hardhat. So we're going to go into the contracts folder, or sorry, the Next.js folder. We haven't really touched Next.js. We didn't do any front end stuff, but there's one config that you're probably going to want to know, and that is the scaffold-config.ts. So this has the chains directory, the target network variable, and we can do chains.sepolia. All of these are going to be available because it's obviously TypeScript, but we're going to do Sepolia. We can also change the polling interval. We can get rid of like a 0. And we could also put in an API key for Alchemy if we wanted here as well. If you have your own API key, you should put it in. Okay, now let's go ahead and load up Scaffold-ETH again. Now you'll notice we got kicked out of the wallet. So first of all, let's take a look at the contracts. These are both going to be unverified. I think I need to actually update the RPC provider too. I think the RPC is completely messed. So let me put my API key in and see if that works, because it's already freaking out. Okay, let's go to API. Let's copy the key, and let's also put that in here. Save it, and then you might need to restart Next.js if you do that. Let's try it again. Okay, so now we're on Sepolia. We have our contract deployed on Sepolia here, so we can see that. We can also see that we got kicked out of the burner wallet. So we don't want to use burner wallets on a test net because they're stored in local storage, so it's not really the most secure way. So we now need to use MetaMask, right? So we're going to connect to MetaMask, hit next, confirm. It wants us to switch networks. We did. And now we're on Sepolia. I have a balance in my address. I have another contract, which is just the hello world, and then I have this year contract, which is an ERC20, and it should have a minted supply of my burner wallet. But oh, you know what? I don't know who I minted it to. Let's see. Let's take a look at the deploy script. What did I do? Your contract deploy your contract. Sorry, where's the contract at? Your contract. Oh, I sent it to the hardhat address. That's okay. Either way, we're not going to actually do a test anyways, but I just want to show that we've deployed successfully here, and we have this kind of like read functionality. So now we should be able to see who deployed the contract. So if we come here, we can click on the address, and we can see that here was when the transaction was done 3 minutes ago from this contract creation, which is here. And yeah, we can also see that it's not verified. So the next thing you probably want to do is verify your contract. So what we can do is come over here and this is going to be fun. Let's see if it works. Yarn verify -- network Sepolia. So that's going to take the contracts and basically like figure out what the bytecode should look like based on what's on on chain versus sending the ABI to Etherscan, I think is what it does, and it's going to verify it. So there we go. Now it's verified. I think because I put my API key in, it's good. So it's going to be good. Yeah. So there we go. That one's verified. This one should be verified now as well. So now if we come back to Etherscan, we can hit refresh, and that contract will have a green check mark. Okay. So that's definitely a cool feature of Scaffold-ETH because you want to verify your contract, especially if you want to use the graph or some other tool that needs the ABI. That way the ABI will be publicly available. Okay, cool. So now we have our contract that was deployed. It's successful. We could basically try to interact with it. Let's just see if we can do that. See, where's it at? Here we go. So we can do balance of Vitalik.eth. It's going to be empty. Yeah, cool. But yeah, we can see that both the contracts are deployed. So cool. All right, what else do we want to show off? We also might want to deploy this somewhere for testing with other users. You want to actually send the URL to someone. So the next thing is you probably want to ship this front end. There's a command for that with Vercel. So we can easily ship the application by doing a yarn Vercel colon YOLO -- prod, which is the most awesome yarn command ever. But what's going to do is it's going to ask you to sign into Vercel. So you can sign in with GitHub, or you can sign in with basically an OAuth hook to Vercel. And then it's going to ask you if you want to set up and deploy. We say yes. It's going to ask you if you want to use an existing scope of projects or what your project scope is. So in mine, it's Kevin Jones Creates. It found our project. I want to create a new one. So I'm going to say no. And then I'm going to not link it to an existing project. I am going to do it to a new one. So I'll just do this, I don't know, Devcon demo. Enter. It asks me where the code is located. I can just hit enter. And now it's going to set up the project. So what it's going to do is create the config file for Vercel and then build it and make sure it builds properly. Set the ports, all that stuff like that. And then it's going to ask if you want to modify the changes. You say no. And then now you can deploy it. So it's going to push it out here. So if we come to this URL now, it takes a second to deploy. We can come here, paste that in. And, oh, I need to be in the right browser session, which is a little annoying. So by default, Vercel will make it private. So you need to authenticate and actually sign in to Vercel. But as you can see here, it's building, so that will take a second. So it's already kind of transferred all the files to Vercel. And now Vercel is running some automation and basically creating a page for me. So at this point, then we'll have this kind of deployed application. We didn't really do any front-end code, but like I said, Edda tomorrow, she will do a much further demo and show you how to use the hooks and the components, reading and writing from your contract, and stuff like that. Okay, cool. I want to talk about one more thing. First of all, let's stop for a second. Sorry about the hiccups. I'm glad that we were actually able to deploy the contract. But are there any questions up until this point that I can answer? Yep. Yeah. Network not supported. Did you do yarn verified -- network?
Yep.
And you typed Sepolia?
No, I use base.
Base, it's base mainnet maybe. So if we go into the hard hat config, so the question was, he was trying to do his verification, but it said network not found. So I think what's going on probably is inside of the hard hat config, we can take a look at what base is called. So I think it's called base, oh, maybe it is called base, yeah.
Base, yeah. So basically, the error message says network with chain ID 8453 not supported. You can specify the URL manually via API URL.
Oh, maybe you can't verify contracts. It's possible that you can't verify contracts for base, possibly. So there might be a manual URL you can pass with the API key using base scan or whatever it's called. So there's probably a way to do it. You need to go to the base block explorer and go to the verification for that contract, and it will tell you how to do it. Cool. Any other questions? Yep. Uh-huh. Let's get you a mic first.
Yes, thank you. I would like to know where to specify the API key for the Block Explorer, because to verify what I read is that we need the Block Explorer API key. So in the structure of the project, where do we specify this key?
Yeah, that's a good question. So I think there's a, let's see if I can do this, yarn verify -- help maybe. I don't know if that's going to work, but there's a way to do -- API key. So you can say yarn verify -- API key, and you can also specify the URL manually. So yeah, it's using hard hat verify. So if you want to look up the documentation for hard hat verify, that's exactly what it uses. At least what my implementation is. If you're using Foundry, it's going to be different. I'm not sure what they use.
And when you verify, does it verify all the contracts?
Yeah.
Or?
Yes.
Okay.
Yeah, like Scaffold-ETH is not like multi-chain out of the box, so it's just going to assume that you want to verify all of the contracts in that project. If they're already verified, it will just skip them. Yeah. Another question over here.
So basically, Scaffold is for NFTs and staking apps. Assuming I would like to do like a computation and add it to a smart contract, if I'm using, I don't know, graph computing or something. Is this possible with Scaffold-ETH, or is this more for like staking apps and NFTs?
I mean, you can write any EVM smart contract with Scaffold-ETH. So if you want to do that inside of the smart contract, then yeah, you can do whatever you need. Any kind of smart contract logic, anything you can write in Solidity, you could write with Scaffold-ETH, right?
But is it made for that, or is it made for the examples made on speedrun Ethereum? Is it made for computation actually, or was it made more for like dApps like staking and so on?
Yeah, it's made more for dApps. It's not really made for like decentralized compute aspect stuff. Like it's not a, I mean, yeah, I'm not sure to answer how to answer it, but basically it's just an Ethereum, tool for building and writing smart contracts. So anything with Solidity, but dApps, yeah, cool. We can talk after if you have more questions. Yep, cool. Any other questions? Sorry, it's hard to see you guys too. I'm like blinded. Okay, cool. I don't think anyone else has questions. No. Cool. All right, now what we're going to do next is, since we have just a little bit more time, I just want to talk about the extension system. Looks like we got like, not sure how long, maybe like 20 minutes, 15 minutes or something. So let's talk about extensions. There is, if you go to the Scaffold-ETH website, scaffold-eth.io, and you go to docs, and you come down here, there's a section called extensions. So I talked about this yesterday. You can probably find the talk available later on after they upload them, where I actually show off an extension. I probably don't have time for that, but there's a list of available extensions here. One of the extensions that I would recommend you check out is the subgraph one, because it has the graph implementation. There's also other ones like on-chain kit and different EIPs, as well as Ponder. And then you can also create your own extension. So it's pretty cool if you are a developer and you want to like showcase Scaffold-ETH, how it integrates with something. You can build out a extension and add the functionality you want. And then every time you want to create a new project, you can just use that extensions framework to start at that point. So really powerful. And also, if you go to scaffold-eth.io and you scroll down, there is a section that is all about components. And there's an extension guide here. And then we have the check out all the available extensions. So you can do it, like I said before, you can do the -e flag, and you can pass in a URL on GitHub. And then here we can get a list of extensions. So here's the subgraph one, EIP, Ponder, ERC20, on-chain kit. There's a bunch of other third-party ones that have been created. So we'd love to see what you guys build. There's a Chainlink one. So if there's something you're trying to do with another integration, you should always check here. There's an Fleek extension, which is really cool. You can deploy to Fleek. So if we didn't want to deploy to Vercel, we might want to deploy to Fleek. You could use that. So yeah, check these out. Highly recommend them. And those are going to be a good point to start. And then also, speedrun Ethereum. So I just want to talk about speedrun Ethereum a little bit more. So speedrun Ethereum, when you first come here, you can connect your wallet, and it's going to create a profile for you with your address. It generates this little like punk. And then you can come in here and go to the main speedrun Ethereum page. Oh, let me reconnect. And you can start a quest. So like the very first one is very, very simple. So I guess my recommendation for anyone that's new to Ethereum, try to do this challenge, because all you have to do is do the first part of what I did, set up Scaffold-ETH, and it's going to let you create this kind of like NFT tool. It's like just an NFT with these little like kind of fun characters, and it's going to walk you through everything you need to do. So it tells you what you need to install. It tells you how to get the repository, go into the repository, check out a specific branch. So it's a little different than just the standard Scaffold-ETH installation, because it is a GitHub repo right here. And so each particular branch is the challenge. So if we go to it, we can show what that looks like here. Let me go. Oh, did I type it in wrong? That's weird. Huh. That's weird. Okay, let me just check the Scaffold-ETH website. What's it called? It's SE2 challenges. So we go to repositories, SE2. Huh, they renamed the repository. Okay. There it is. Okay. So this is the challenges repository. If you click here on main, you can see all the challenges here. So 0 through all the way down to 7, SVG NFT. So yeah, you can just choose that repository, and then each one is going to have all of the instructions as well here. So you can do it either way, but when you're ready to actually submit your progress, you come all the way to the bottom, and you hit Submit Challenge. And it's going to ask you where you deployed it. So earlier, I showed you guys how to deploy to Vercel, which we should have done, actually. Let's see if it went through successfully. Oh, shoot, did I lose it? I had it here. I don't know where it went. Anyways, it will give you the URL that I typed in and put in. So you need to put that URL right here. And then you also need to put the contract address that is verified on Etherscan. So basically, it's going to ask you to deploy everything to Sepolia. So you just need to put that Sepolia Etherscan. The contract also needs to be verified, because we do some automation to like verify your contract. So I would recommend everyone try to do at least challenge 0 before the end of the week. It literally will take you like 20 minutes to do. And then that will kind of set you up to start learning a little bit more. And then you can learn, again, how to do like staking. So this will go into like how you stake. You do like a token staking. This is how you do like a token vendor, where you can actually like deposit one asset and get back another. And then again, this talks about randomness, and then eventually you build like a DEX, which is a lot more complicated, but you learn a lot, because then you start to learn about slippage and stuff like that, and understand how a DEX works, decentralized exchange. Cool. Okay, cool. I think we're gonna probably end a little early unless there's questions. Does anyone have questions at all? Yep, question here.
Yes, I would like to know, when you submit your challenge, is it verified by a human being behind the scene, or is it automatic? Do I need, for example, to send a video to show that my contract respects the specification?
Yeah, so it's all automated pretty much. We just, the way we do it is the first few challenges we do automated, so we just get the the Etherscan address, and then we pull down the source code and then test it. So we run like a test. So each challenge has a test. So if the hard hat test passes on your local machine, it's going to pass on the automation, so we verify it. When it gets down to the DEX, it's done all manually. So we actually look at the code and make sure that it's good. You don't need to do a video, though. And especially these last few, like the state channel, multi-sig, and SVG, those are also all manual, pretty much. Yeah. What other questions we have? I think I saw another hand, but I don't know where it was. No? No? Cool. Awesome. Thank you guys so much for coming, and I hope you guys learned something and it was useful. Thank you.